So I find myself with some free time again and set out to make some videos. I did a little poll to see like what people would be interested in seeing. I know there's a lot of interest in military history. I'm hoping later this week, fingers crossed, I'll actually go somewhere and do a little location filming for a military history video. But in the meantime, I wanted to work on something that I could get finished from home. The topic that I think kind of won the poll was home automation and Z Wave. I spend an inordinate amount of my mental effort on home automation, I think. And just to start out, I want to be completely clear. Home automation is a hell of a drug, and winners don't do home automation. Um, I kind of first, I think, caught the home automation addiction probably 7 years ago. I had a Mikasa Verde Z-Wave hub. Mikasa Verde, they're still around. They rebranded to Eslo. Honestly, I hated that hub. I wouldn't hold it against them because that was like 7 years ago, and I assume that a lot of the rough edges on that product have probably been smoothed out. But I have a lot of stuff that I've set up. I'm mostly using open source software. I mostly use Z-Wave and MQTT. There's a lot of things that I wrote the software myself that I have running. And I want to kind of share a lot of what I've done with home automation. I also think that talking about some of the stuff I've put together on YouTube will be a good motivation to finally get the software to, I'll call it a level of refinement where I could, open source it and expect other people to use it without feeling bad. To be fair, actually, most of it is open source. Most of it's public on my GitLab. It's just a lot of it. It's got like hard coded configuration. The documentation is wrong. I haven't really put a release level of polish into most of the stuff I've built. So I know I'll make some videos about that. I want to make some videos about some Z-Wave devices too, because I think it can be surprisingly hard to get good information on how a lot of Z-Wave devices function in practice. So I was kind of thinking I'd do some reviews effectively. But here's the thing. When I talked about this on Mastodon, an old friend of mine, Chris, said that he'd like to see something where I talked about the different radio protocols. And I thought, well, that's kind of boring and dry material, but honestly, I should cover it before I kind of go into more details on Z-Wave. So that's what I'm going to do in this video. It's going to be a little bit boring. It's going to be a little lecture style, but I want to give you a good background on the control protocols that are in common use for home automation right now. If you've read my stuff, I think you know that networking is kind of my biggest interest. So I'm really going to focus on the interconnect protocols more than I will on the software aspect. I use Home Assistant. Most people use Home Assistant. I probably wouldn't use anything but Home Assistant at this point. I used to use OpenHAB. That's a whole story, right? But do not do OpenHAB. But I'm not going to talk about that so much. I'm going to focus more on the network protocols. So let's get started out with talking a little bit about what is home automation. One of the most common things that people want to automate is lighting. So we have some sort of smart, I'm going to put that in air quotes, lighting. I'll try to make the parts of my handwriting that are actually important legible, but you know what? This is what you get right now. We might also have sensors in the house. If you're kind of coming at this from a more academic or commercial perspective, people talk a lot about sensors and actuators. Those are kind of the academic terms. So a sensor might be something like a door closure, one of these guys that tells us whether a door is open or closed. And an actuator could be something like a light bulb where we can alter the brightness, the color, that sort of thing. Inside of our home, we have these devices, and then somewhere out there is the internet. This is one of the first kind of fundamental divides we'll hit in home automation, is whether devices are cloud dependent or not. A lot of the cheaper, more consumer-oriented home automation devices that you'll find are completely cloud dependent. So your sensors, your devices, they all connect directly to, probably AWS or some other backend service. But there is another approach too. The other approach is that we can have some sort of household device. Could be called a hub, a controller, a gateway. There's kind of technical differences between those terms, but people don't use them consistently, so don't worry about it too much. We could have our devices connect to that device in our house, and then it connects out to some cloud service. Why do we need the cloud service? Because I know a lot of people who are in a more technical audience are going to look at this and say, I don't want the cloud at all, right? Here's the thing. Consumers want their home automation set up to work, regardless of whether they are in their home on their home network. And the realities of the internet, of ubiquitous NAT on residential internet connections, mean that not necessarily, I mean, in a technical sense, the only way to achieve that is with some sort of cloud service in a lot of cases if we can't deal with NAT. But from a practical perspective, it's just, even in situations where we could avoid it, by far the easiest thing for a device manufacturer to do is to operate some cloud service. The device connects to the cloud service, the mobile app connects to the cloud service. Now we never have to worry about the actual network situation. The downside to cloud dependent devices, well, there's kind of two big downsides we could focus on. One of them is there's sort of a privacy, I'd almost call it a sovereignty concern. A lot of people don't like having devices in their house that are sort of under external control by some vendor. The second concern is kind of reliability and performance. Devices that are totally cloud dependent, if your internet connection isn't working, they don't work. Depending on where you live and the quality of your ISP, that could be a big practical problem. They also, I don't see people bring this up as much, but they tend to be slow. A lot of the cloud services have a surprising amount of latency. So you end up with like the response time to a command being like 5 seconds, which is really annoying when it's like something in your house that you're looking at. So one of the big advantages to having more local control is actually reduced latency, or at least you get more control over the latency. I can't always get it as low as I would like to, but for the most part, all the devices in my house, there's no perceptible latency between, tapping something in an app and an event happening. And that's because I'm keeping all that communication local. So let's kind of talk about where these protocols fit into this model. On the internet side, it's going to be IP, right? There's just not really another option. And most of the time, it's going to be HTTPS, right? Because this is 2023, and we have largely forgotten that other network protocols exist. But on the home side, there is a lot more flexibility. That's equipment that we own. It's equipment that can kind of use whatever wireless protocol we want. Yet, most of the time, vendors are targeting Wi-Fi. Why is that? Because you already have Wi-Fi in your house. So, Wi-Fi is kind of the only option that IoT devices can rely on that you will already have in place. Pretty much anything else, you're going to need some sort of hub or gateway. Consumers find gateways really annoying, right? I mean, I find gateways really annoying just because of the number of them that I have in my closet and all the power adapters for them. It's awful. And in a lot of cases, because of closed vendor systems, you're going to end up with more than one. So let's talk about that differentiation real quick as well. In the home automation world, there are closed systems and there are open systems. You could define these different ways. The way I'm going to use these terms is that open systems allow multiple vendors to manufacture and sell products that use that same control network. Closed systems don't. Closed systems are more common. Almost all Wi-Fi devices are in a closed system. You can't interact with them from other vendors' products. When it comes to other radio protocols, it just varies. There's a lot of open systems and a lot of closed systems that often use the same protocols, which often does mean that you can kind of get away with joining things to closed systems that weren't supposed to be there. People who've had Hue for a while probably kind of remember that deal. You used to be able to pair non-Philips Zigbee devices with the Hue hub because Hue uses Zigbee under the hood. Then they removed that capability. Now it's for like certified devices only. So open or closed is a big difference. As you would imagine, I try very hard to avoid closed systems. So the protocols that I'm about to talk about, I'm going to talk about them in the context of an open system where you control it, but be aware that there are a number of closed systems that are actually using the same radio protocols under the hood, and they may or may not have measures in place to prevent you connecting a device from a different vendor to that network. Burglar alarms, subject I've talked about before. A lot of the new consumer burglar alarms are using Z-Wave or Zigbee, at least for some of their devices, but they often either don't allow you to connect devices from other vendors or impose a lot of limitations on them. Let me say something real quick about burglar alarms, too. Basically, every consumer burglar alarm advertises that it is a home automation platform. They are all lying. I have never seen an exception. Every burglar alarm I've seen with home automation features is just garbage. It's the most half assed, lazy attempt at saying that they have a home automation product. One of the tricky details of this home cloud split is that in a lot of practical home automation applications, there's more than one protocol actually involved. So, a really common situation is that some smart device that you have in your house, maybe by the end of this video, I'll actually be able to draw a light bulb, but I cannot promise. A lot of the smart devices in your house are going to communicate with the hub over a protocol like Z-Wave, and then the hub is going to communicate with a cloud service over IP. So, an implication there is that even if there is a hub, that doesn't necessarily mean that there's a local control capability. In some cases, the hub, or more properly, you'd call it a gateway in this case, has no actual logic on board. It's really just doing protocol translation to allow devices using a non Wi Fi radio or a non IP radio protocol to communicate with cloud services. In other cases, the hub is a proper controller. It is a thick device which applies its own like logic and rules engine to events so that you can implement automation locally. That really just varies from product to product. Sometimes there are local capabilities that are limited. Some features require an active cloud connection. It's really all over the place. When it comes to IoT devices, there are basically 5 radio protocols that matter. There's some stuff that I'm leaving out of this list. So there's Insteon, for example. Insteon has some interesting properties. I would kind of love to mess with it. I have never personally seen an Insteon device or even really people that sell them. I think Insteon has fallen out of popularity, but I couldn't tell you this for sure, but I don't think Insteon was ever very popular in the United States. I think a lot of the Insteon, actual Insteon use was in Europe, so I just haven't really run into it here. But it seems like Insteon's going away. I don't think anyone is installing it now. Another example that comes to mind is X10. There is kind of a fascinating story that I will write something about or make a video about eventually of like what happened to X10 as a consumer brand. But X10 was kind of the first practical radio home automation kind of. I would be amazed to find an X10 network that is still operating today. Old protocol, very basic, lots of practical problems. So there's 5 that I think really matter: Wi-Fi, Bluetooth, Zigbee, Z-Wave, and Thread. So let's talk about Wi-Fi first. Wi-Fi is the most obvious choice. The great thing about Wi-Fi, it works. We've already got it. You get direct internet connectivity over Wi-Fi, so it's really friendly to devices that are dependent on a cloud service. So what's the problem with Wi-Fi? Why don't we use Wi-Fi for everything? Well, there's a few different problems, but the biggest by far is power consumption. So these like Wi-Fi smart outlets, these are really, really common. And Wi-Fi is a good fit for these because they are plugged into the wall. They have a constant source of electricity, and so their power consumption, besides maybe having a negligible impact on driving up your power bill, doesn't matter a lot. Where Wi-Fi really falls flat is with battery powered devices. So things like sensors are often not installed somewhere with convenient access to power. We can also imagine remotes, key fobs, that sort of thing. There are battery powered IoT Wi Fi devices, but they tend to really suffer on the battery life standpoint because a lot of like practical home automation devices they run off of a coin cell, right? When it comes to sensors, to be practical, you basically need to have like a year plus lifespan off of like a CR2032 or maybe a little thicker coin cell. You just can't really do that with Wi Fi. So, Wi Fi, good for our constantly powered devices, not good for anything battery powered. Wi Fi almost always implies dependency on a cloud service. Most of those cloud services are closed. A notable exception that you will run into a lot is Tuya. Tuya is a large Chinese company that produces like a turnkey IoT platform. So Tuya operates the cloud backend. They also provide the firmware images for devices. If you just go on like Amazon and type in Smart Outlet, which I think is how I bought these are Gosuna brand, but I'm sure you can probably find this exact same unit sold under a bunch of different, often 6 letter names. These cheap smart outlets are almost always Tuya. Same deal for cheap Wi Fi light bulbs. The great thing about Tuya is that on the standard Tuya cloud, it is a very straightforward process to get a developer account and then API credentials. And then you can actually programmatically interact with these from your own software without reverse engineering or screen scraping or any of the horrifying bullshit that people often do to get programmatic control over IoT devices. Funny, isn't it, that programmatic control was the whole promise of IoT, and yet we are often struggling to make it happen. That's because of the incentives of capitalism. But I'll save that for a different video. So Tuya is great because a straight up Tuya device you can get API control over. How do you know if it's a straight up Tuya device? If the documentation tells you to use the Smart Life app. Smart Life is like the first party official app for interacting with the Tuya cloud. An interesting thing about Tuya is that there's also a lot of devices out there that are white labeled Tuya products. So they are using Tuya, they use the Tuya cloud, they use the Tuya firmware image, but the documentation tells you to install some other app that's specific to the brand that sold them. You see a lot of these at Walmart. Monoprice used to have a line of like home auto. I think they discontinued it, but they had a line of Wi-Fi home automation stuff that was white labeled Tuya. White labeled Tuya products, the problem with them is that the API credentials that you can just get by signing up as a developer with Tuya only work for what I'm calling straight up Tuya. The white labeled products are in like a separate tenant of the Tuya cloud, and they're not accessible from the Tuya API unless you have credentials like to that tenant. But companies do the whole white labeling thing because they want to have a closed system, so they're not going to easily give you those credentials. A cool thing, though, is that a surprising number of white labeled Tuya products, the firmware on them isn't actually locked down. So whenever you get a cheap Wi-Fi IoT thing, just try setting it up with the Smart Life app. It might just work, and then it will be provisioned in the normal Tuya cloud, which means you'll have API access to it. And even if you don't care about the API, it just means that you won't have to install whatever stupid app. So that's the Wi-Fi story. Let's talk a bit about Bluetooth. I actually don't think that these use Bluetooth even for the initial setup. There's a weird, I'm just realizing that's not Gosuna, that's Gosund. It's in a different font on the back, and I can tell that's a D. You would not think that looking at the front. Anyway, Bluetooth. So the thing about Bluetooth is that Bluetooth actually has a lot of the same limitations for IoT and embedded applications that Wi-Fi does. It's very session oriented. Devices are expected to kind of be awake all the time to maintain an association, and that's really hard on battery life. The way that sensors achieve a year plus battery life is by waking up when they have a message to send and then going to sleep for the next like 24 hours. You cannot maintain an association with Wi-Fi or Bluetooth that way. Fortunately, the geniuses in charge of Bluetooth, they basically took a totally separate protocol and stapled it onto the Bluetooth spec and called it Bluetooth Low Energy. That description is a little unfair because I think it was developed from the beginning to be a complement to the Bluetooth spec, but it's important to understand that Bluetooth and BLE are two totally separate protocols. The commonality between them is that they operate in the same band with some similar modulations, which means that it's fairly easy for one chip to implement both. Um, Incidentally, that's a commonality that Wi Fi shares with Bluetooth as well, which is why in a lot of consumer devices, phones, laptops, there is one chip that does Wi Fi, Bluetooth, and BLE. You might naturally wonder, given that fact, could we also staple the 802.11 specification onto the Bluetooth spec and call it a Bluetooth extension? And the answer is yes. Um, Modern, like Bluetooth, I'm not going to get the name of the spec right, but the kind of most recent Bluetooth high speed specs, they actually use 802.11 for communication between the devices. The Bluetooth protocol itself is used for the initial negotiation, but after that, it's essentially a Wi Fi point to point connection. And that's kind of why Wi Fi Direct died out, because basically Wi Fi Direct just got subsumed by Bluetooth. So, Bluetooth, the point is, Bluetooth is this weird monstrosity. It's like several different radio protocols that have been stuck together into one protocol suite, and one of them is BLE. BLE is specifically oriented towards low powered devices. Um, BLE is not session oriented, so it doesn't have the sense of association that we have with Bluetooth. BLE devices can just send packets, and the only real sense of association is that there's some header fields to keep track of like what a packet is destined for. You can get phone apps that just show you the BLE traffic that's occurring around you, and what you will see is every Apple device within 100 feet, because most Apple products have like a continuous BLE beacon that I think it's used to facilitate like AirDrop and that sort of application. But there's lots of other things that use BLE too, and they're home automation devices that use BLE. Light bulbs, I see a lot of BLE light bulbs. I said earlier that I was kind of leaving Bluetooth out here. The reason for that is that Bluetooth and BLE are rarely used as a home automation protocol. They're usually just used as a remote control protocol. And what I mean by that is that, like, a BLE light bulb means that you can control it from your phone when you are near the light bulb. It's just like that point to point connection for control. You don't really have the ability to form a larger network where you have a gateway to a cloud service, where you can have a logic engine that implements automation rules. You don't really get that kind of thing with BLE. That's not really a technical limitation. It's possible to build that sort of thing with BLE. I actually have a couple products that do that from a company called Govi, but it's just not very common in my experience. So I don't think as a consumer you're very likely to run into BLE devices that have like real home automation capabilities. So let's talk about the protocols that I really care about: Zigbee, Z-Wave, and Thread. Let's start with Z-Wave, because Z-Wave is kind of the oldest, currently popular dedicated radio protocol for home automation. Z-Wave was designed originally, I think, by a company called Zensys, which was bought by another company that was called Sigma, maybe, which was bought by Silicon Labs. Z-Wave was designed from the ground up to be a home automation protocol. So it really has all of the kind of home automation ideas baked in. That gives Z-Wave some interesting capabilities that Zigbee, which originated as a general purpose mesh radio protocol, does not have. We'll get to the whole Zigbee story, but Z-Wave has always been about home automation. Kind of the weird thing about Z-Wave, and probably its biggest downside, is that Z-Wave for a long time was proprietary. Just in the last 3 years, I think, Z-Wave 800 series, I'll talk about that, has been accepted as an ITU standard. There's things like implementation, like reference implementation, source code, and designs are now shared in the Z-Wave Alliance. So the expectation is that in the future there will be multiple vendors of Z-Wave chips. But for the time being, it's still basically the case that every Z-Wave chip is manufactured by Silicon Labs. One downside that has, there is a Z-Wave price premium. A Z-Wave product will usually cost a little bit more than a similar Zigbee product. And what I've been told is that that's really just because the BOM cost of the Z-Wave chips from Silicon Labs is relatively high. That's probably the biggest downside of Z-Wave, is that it's a little more expensive. The other downside of Z-Wave you'll hear people talk about is that it's relatively limited on the size of a Z-Wave network. There's a limit on the total number of nodes. Historically, that was like 60 something, then it got raised to 200 something. Now it's actually 4,000, but that's only for like the latest generation chips. There's also a limitation on the number of hops the traffic will be routed through. So Z-Wave is a mesh networking protocol. That's great because the range of Z-Wave is not really that long. It's like tens of meters open space, I think. So the mesh networking capability really helps with having reliable communications, even just across the scale of a house. But there is a limitation in Z-Wave that packets will only be forwarded through 4 hops. I don't think those limitations are that important in practice. Having more than one hop in a network path is already kind of considered a bad thing because it adds latency. And I just don't think many people. There are other limiting factors that you are going to hit before you hit that node count limit. Even when it was 200 some, especially now that it's 4,000 with the latest generation chips. It's frustrating because Z-Wave and Zigbee are both popular right now. And when you like Google Z-Wave versus Zigbee, which should I use? A lot of the articles you'll get are based on like really outdated information. So it's important that you kind of try to follow up on newer materials and what changes have happened to the specs since then. Because I've seen a lot of articles that say negatives about Z-Wave that aren't true anymore, like having a node limit of 60 some. That hasn't been true for years and years. I also see articles that say bad things about Zigbee, like there being no standard for interoperability. That also hasn't been true for years and years. So it's actually a surprisingly dynamic situation for how old these protocols are. And things have changed a lot, even just since like pre-COVID. The big upsides of Z-Wave are long battery life. Z-Wave was specifically built to accommodate low power sensors. I routinely get 1 to 2 year battery life out of Z-Wave devices that run off of a coin cell. I have some that have been going for longer than that if they only have to report something infrequently. Another big advantage of Z-Wave is that the level of interoperability in Z-Wave is very good. Since the very beginning, Z-Wave has had interoperability baked into the specification. There are pretty detailed standards for how Z-Wave devices expose their capabilities to the network and how a controller or a hub enumerates them. So it's not perfect, but Z-Wave is pretty good. Most of the time you can buy any old Z-Wave device and it will work correctly with whatever hub or controller you have, including exposing the right options and that sort of thing. A third upside to Z-Wave is that it operates in the 900 megahertz ISM band. Zigbee operates in the 2.4 gigahertz ISM band along with Wi-Fi and Bluetooth. It doesn't strictly have to. 900 megahertz is supported, but every consumer Zigbee IoT device I have seen is 2.4 gigahertz. I think the 900 megahertz band isn't allocated that way in Europe, so I think that's part of the difference. You'd only be able to sell it in the US, or you'd have to have different variants for the US and European markets if you did the sub gigahertz. So that means that Z-Wave has fewer band contention problems than Zigbee. Zigbee, you can have Wi-Fi interfering. That can get pretty bad in urban areas. You will not have that problem with Z-Wave. There are way fewer 900 megahertz ISM devices out there. So how does Z-Wave actually work in practice? Z-Wave is the platform that I know the most about because I have used it since 2016 or something like that. There is a big ecosystem of Z-Wave controllers that are like a dedicated hardware products. Ezlo, the company that used to be Mi Casa Verde that I used ages and ages ago, they still have theirs. As far as I know, it's still based on their kind of funky Lua runtime, which is kind of cool because you can write your automations in Lua, which is really flexible. At least back in 2016, it was annoying because every time you changed anything, it had to restart the whole Lua runtime, and that took like a full minute somehow. I imagine that's not as annoying anymore. Most people that are watching this video, though, I think are going to want to use open source software. So it's a lot more likely that you're going to get one of these USB sticks. This is an older one that I replaced just to go to a newer Z-Wave generation, and I'll talk about that in a minute. But you get one of these USB sticks. They're cheap. They're like 30 bucks or something. You plug it in, shows up as a serial device, and then you use some sort of software. Most of the time, the software you're going to use is Z-Wave.js. There are other approaches, but Z-Wave.js seems to be winning out over everything else. That's like a Node.js application that interacts with this controller to send and receive commands. An interesting thing, there's a few interesting things about how Z-Wave works with software, but one of them is that Z-Wave chips, they have like flash storage, and they keep all of their like association and basic configuration on board. So if you pair this stick with Z-Wave devices and then unplug it and plug it into a different computer, it is still paired with those devices. Interesting property of Z-Wave. Sometimes it's nice, sometimes it's annoying, but it's definitely a big difference from Zigbee. Z-Wave.js, it's available as an add-on for Home Assistant. That's the way that a lot of people will use it. Little Home Assistant tip. If you're a Home Assistant user, I would, instead of using the official Z-Wave.js add-on, go through Hacks, the community store, and install the Z-Wave.js UI add-on. It is the exact same underlying software, but it exposes the built-in web interface that Z-Wave.js has. We'll look at that. Let's look at that right now. I have a screen recorder. I can do this shit. So let's take a quick look at how this works in Home Assistant. This is not by any means going to be a Home Assistant tutorial, but since I do have a fairly large Z-Wave system up and running, I think it'll just be an easy way to demonstrate the ideas. As I said, I highly recommend that you use the Z-Wave.js UI community add-on rather than the official Z-Wave.js add-on. The only difference is that Z-Wave.js UI gives us this Open Web UI button that exposes the built-in web UI of Z-Wave.js. And this kind of gives us a lot more under-the-hood detail than Home Assistant does. Since Home Assistant is kind of like generic home automation software, it doesn't have the depth of supporting kind of the details of Z-Wave that Z-Wave.js's own interface has. One of the most important things about Z-Wave and Zigbee is that they're mesh network protocols. So this kind of illustration of my house in a certain radio sense shows the network topology that's been built. I have very thick adobe walls in my house. It's an old house, which makes it a challenging case for these radio protocols, despite how small it is. So I have kind of a surprising number of devices that are running off of multiple hops. A lot of people, they look at this kind of thing. Why is this dead? Oh, I know exactly why that's dead. There's a story there. So a lot of people who look at Z-Wave, one of the first things they get a little confused about is what exactly a repeater is, because there are like purpose-built Z-Wave range extenders. Here's the thing about Z-Wave. Any device that has a constant source of electricity, meaning that it's plugged in, will function as a repeater in a Z-Wave network. The devices that won't function as repeaters are devices that are battery powered, because it would tank their battery life to have to be awake all the time to listen for messages that they should repeat. So most of the time, you probably won't need any dedicated Z-Wave repeaters. If you have enough like smart plugs, in-wall dimmers, those kinds of things that are hooked up to mains power, then you should have plenty to kind of build up a good network topology. I only have one situation where I use a dedicated repeater, and it's because I'm doing something kind of weird to get Z-Wave traffic into an outbuilding that's just really challenging to get a signal to. Also in Z-Wave.js, this is a probabilistic graph layout algorithm, so I cannot smoothly get away with like cutting back and acting like I didn't edit something in between, right? But also in the Z-Wave JS UI, we have a list of all the devices on the network. This is helpful because Z-Wave JS really shows us the underlying like details. So Z-Wave in the specification has a sense of a command class. A command class is a set of capabilities that a device has. So everything we're seeing under values, these are the command classes that this device supports. And this particular device is, if I'm not mistaken, yeah, this is an in-wall dimmer. I think it controls an overhead light in one of the rooms in this house. One downside of this web UI is it's not very well integrated. Well, it's not at all integrated with Home Assistant. So it doesn't know the names that devices have in Home Assistant. That's why you're just seeing like node numbers places. I could set the name here too, but I haven't bothered to do that. So we can see this supports the basic V2 command class. There is basically nothing in there except for a really simple event capability. It supports the multi-level switch V4 command class. Here we have things that make sense for a dimmer. We have a target value, that's basically how bright. We have a current value. We have information on a fade it's currently executing. We have the ability to start fades. We have a scene controller capability. I don't know that I'll go into too much depth on this because it could kind of occupy a whole video. But one of the cool things about Z-Wave, because it was built from the ground up as a home automation protocol, is that Z-Wave has internal support for scenes and associations between devices. So, say, for example, a Z-Wave remote can control a Z-Wave light without the controller being involved. They can be directly associated. Z-Wave devices can also save scenes so that a scene can be recalled with a single Z-Wave command rather than sending levels to multiple devices involved in a scene. Really cool capability of Z-Wave. The problem is that basically only Z-Wave has that capability, so like Home Assistant doesn't really support it at all. You have to use the Z-Wave JS UI to interact with those features, and it's kind of awkward how you do it. Another thing to know about Z-Wave is that a lot of Z-Wave devices expose configuration options over Z-Wave itself using the configuration command class. So if we look at this dimmer, we can see the configuration v4 includes just a bunch of variables we can set. Dim rate, whether the LED indicator on the switch should be on or off, minimum and maximum thresholds, which are useful if you're dealing with kind of weird lighting loads that misbehave at the extreme bottom or top end. Or I'll be honest, this is a little bit of a hack that I don't love, but I'll often use the maximum dimmer threshold if I have basically overloaded the power supply on some low voltage lighting. You have like an LED strip, you do the watts per meter, it's a little bit more than your power supply. How do you fix that? You set the maximum dimmer threshold. So this is useful to have. Some of the other home automation protocols, there's no consistency about how this is exposed. I would love to say that Z-Wave having integrated configuration support means that it's a super good, consistent user experience across different software platforms. It's actually not. A lot of the commercial controllers like barely expose this to the user. But I will say Home Assistant is actually pretty good about it. So if we navigate to this device. I don't know for sure which device that even was. I would have to check the node numbers, but it's probably the overhead light in the bedroom. If we hit configure, this is actually Home Assistant itself. Yeah, this has more options. It's funny. There's something you'll see with Z-Wave is that one company will manufacture the hardware, and then different companies will sell it with different firmware. So I have two different in-wall dimmers. One is GE Jasco, the other is Zooz. I'm not 100% sure, but I think they are identical hardware and they just have different firmware. The Zooz one has more flexible firmware than the GE Jasco one does. It exposes more options and has more complete support for direct associations. So that is a weird thing about Z-Wave. Another example, I have this 4-button scene remote that I bought off AliExpress. Works fine. Zooz just announced a new 4-button scene remote. It's the exact same one I have. I'll probably buy it from them because I suspect that yet again they will have better, more configurable firmware on it. But it's an oddity of the Z-Wave ecosystem. There's a lot of like kind of white labeling and reselling of devices. Sometimes they actually are identical, but sometimes the software, which is kind of what matters, is different. The last bit that I want to say about Z-Wave has to do with versions. As I said, these protocols have all gone through changes over the years. Z-Wave is no exception. Z-Wave, it's a little weird. There's logos. There's like, I'm pretty sure on the back of this, yeah, it says Z-Wave Plus. The camera didn't even focus on this. What am I doing? But most people in practice, they tend to refer to Z-Wave versions by the part number of the Silicon Labs chip that implements it. So people talk about 500 series, 700 series, and 800 series, which is the latest Z-Wave. I don't know what happened to 600 series. 500 series Z-Wave is like the OG implementation of Z-Wave. It's actually very limited compared to more modern Z-Wave devices, both in terms of network capabilities, things like encryption. It doesn't really have authenticated encryption. 700 series added more flexible mesh routing support. It added a much better encryption protocol, which is called S2 Secure. And then 800 series, which came along relatively recently, besides a bunch of like general enhancements. 800 series introduced a new modulation, which is called 800LR, or Z-Wave Long Range. Z-Wave Long Range actually has an open space range of, I've read, up to a mile. So if you have a bigger property or you're struggling with range issues, if you can stick to all 800LR devices, you should have a much better experience. I'm starting to switch. That's actually why I have this. I used this USB dongle for years and years. It is taped together because the case broke open when I dropped it at some point. This is out sitting around because I recently switched to an 800 series USB dongle. This one is 700 series because I wanted that long range support. Really helps with getting to the shed. Another big change with 800 series is that the 800LR protocol supports up to 4,000 devices. You are just not going to hit that number in real practice, so I think we can basically say that the number of devices on a Z-Wave network is unlimited at this point. I am kind of referring to 800LR as a different protocol. Under the hood, it uses like a different modulation scheme. But don't worry about it. The way it's kind of added to the other Z-Wave protocols, it behaves very transparently. So 800LR devices can communicate with 500 and 700 series devices. Really try to avoid anything 500 series at this point. You really shouldn't be installing non-Z-Wave Plus, non-700 or 800 series devices. They're pretty much obsolete at this point. Okay, our next contestant is Zigbee. But before we talk about Zigbee, we should go a little bit lower in the stack and briefly talk about IEEE 802.15.4. 802.15.4 is a low-power wireless personal area network standard, and it's used as the underlying protocol, like basically the physical and data link layer, for several different higher-level protocols. Zigbee is one of those. So Zigbee is a protocol which runs on top of 802.15.4. For some reason, for years, I thought that Z-Wave also runs on top of 802.15.4. It doesn't. Unrelated physical implementation. There are some similarities between Z-Wave and 802.15.4, but I think they're sort of coincidental. As far as I can tell, they were developed totally separately from each other. So 802.15.4 is, it's really just like a point-to-point protocol. It doesn't have like kind of routing logic or application logic on top of it. Zigbee fills a lot of that in. Zigbee was developed as a general-purpose, low-power mesh networking protocol. I remember back in college, there was a professor who was doing, people who went to college with me are going to laugh about me mentioning him seriously, but there was a professor who was doing research related to sensor networks, and they were using Zigbee for a lot of those sensor network applications. Zigbee, it wasn't built for home automation like Z-Wave was, and so its application to home automation for years was awkward. Zigbee, it's always been an open system, but there used to be no interoperability standard. So whether or not a given Zigbee device would work with like your controller or whatever you have was a total mystery and was basically up to the vendors to sort out. That has changed. The Zigbee 3.0 specification actually added a standardized application layer, a lot like what Z-Wave has. So newer Zigbee devices, They should have much easier interoperability with each other. I just don't think you're really going to run into that problem with like, does my controller actually support this thing, as long as you're sticking to Zigbee 3.0. And it's been out for long enough that I don't think you're going to see a lot of devices on the market that don't support it. I want to say it's been out for like 4 years now. The biggest upside of Zigbee is that it's a way more open ecosystem, which has pushed the prices way down. Zigbee devices are pretty consistently cheaper than Z Wave devices, and in general, there's a larger selection of them. Getting kind of the certification to sell a device with the Z Wave logo is kind of a complicated process. There's not that many vendors that sell Z Wave devices, and if you do Z Wave, like you pretty quickly just know you got Zeus, GE Jasco, Fibero, EOTech. That's like almost the whole list right there, right? I think I might be leaving out maybe a fifth and sixth company. Zigbee, there's like, just search AliExpress for Zigbee, right? There are so many Zigbee products out there. I do think I don't heavily use Zigbee. I actually don't even have a Zigbee radio hooked up right now, although that's temporary. I'll go back to having one. My experience is that because of the lack of a qualification process, the quality of Zigbee devices, like quality and usability, is a lot more variable than Z Wave devices. But then they're considerably cheaper. So, you get what you pay for, and that's not always a bad thing. One of the benefits that people often tout of Zigbee is that it supports larger networks than Z Wave. I don't, number one, I don't think that that's really true anymore with more recent enhancements to the Z Wave protocol. Number two, I don't think you're going to hit really the network size limit on either protocol. There's practical issues around bandwidth and contention that I think are going to be the limiting factor these days before you get to like the limitations on node count and hop length. But Zigbee, it basically has no practical limit on node count, and it has no practical limit on the number of hops. So it is more flexible, especially in a very large system than Z Wave. At the scale of a house, I don't think it's likely to matter. The biggest downside of Zigbee, I would say, besides the more variable quality, is that practical Zigbee devices, like the Zigbee products that you can go buy right now, operate in the 2.4 gigahertz ISM band, so they are in contention with Wi Fi and Bluetooth. If you're in a dense urban area, that could become a real problem for the reliability of your Zigbee network. If you're in a more suburban or rural setting, may not matter to you at all. Most of the time, people say that Zigbee will achieve a longer range. I don't think that's true anymore with Z Wave 800LR, but there's only so many 800LR devices on the market right now. So in practice, it might be easier to get Zigbee devices that'll function over a long range than Z Wave. But for the most part, Z Wave and Zigbee are really similar. The most frustrating thing is that there kind of isn't an obvious direction to go. You can totally use both with like Home Assistant. You can have a Z Wave dongle and a Zigbee dongle plugged in. You can use Zigbee to MQTT, Zigbee for MQTT, whatever. There's an add-on for Home Assistant that exposes Zigbee devices via MQTT, which is probably something I'll talk about in a future video. That's an IP-based like message bus protocol. I use MQTT very heavily in my house. Basically, everything that I've implemented is based on MQTT, and I have been slowly replacing parts of Home Assistant with like an MQTT sort of logic engine that I've been building, just because it's simpler and it performs a little bit faster. But overall, I have a hard time giving people advice on should I use Z Wave or should I use Zigbee, other than try to stick to one of them for convenience. But if it really comes down to it, you can use both. And that takes us to Thread and Matter. Matter is like a higher level architecture for how home automation devices should function, particularly when it comes to interactions between vendors. The closest equivalent to Matter from like a protocol stack perspective is HomeKit. And Matter serves a pretty similar role in trying to make IoT products from different vendors reasonably interoperable with each other. I have not personally taken the dive on Matter yet. I read an article recently, maybe from Wired, but don't quote me on that, where they tried out a bunch of Matter devices. It seems like it's kind of a mixed bag how that actually functions right now. But then my experience is that HomeKit is a pretty mixed bag. I say this with the caveat that I am not an iOS user or a Mac user in general, and maybe I'd feel differently if I was. My experiences with HomeKit have been pretty poor, and I try to avoid these days buying any product where I would have to use HomeKit for interoperability. I've had reliability issues. I found it frustrating to set up, and I found that the HomeKit interface that devices offer is often very limited compared to the capabilities they have through their first party app or their API or whatever other option you get. I'm hearing Matter has a really similar problem. Like the Matter interface that Hue devices expose is really limited compared to what's available over the HTTP API that the Hue bridge offers. Thread is one of the protocols that Matter devices can use to communicate. So Matter devices can use Wi-Fi or they can use Thread. I think Bluetooth is also in the mix, but I think it may just be for initial setup of Wi-Fi and maybe Thread connections. The interesting thing about Matter is that it's all IP. So obviously Wi-Fi devices are doing IP over Wi-Fi. But Thread, which is for your low power, your battery powered, those kinds of embedded devices, is also IP. Thread is it's based on 802.15.4, so the same underlying physical protocol as Zigbee. But on top of 802.15.4, Thread runs 6LoWPAN. If I had better researched this, I would know what 6LoWPAN stood for. I think it might be IPv6 over low power wireless personal area networks, maybe. I'm going to give myself a ding if I got that correctly. But that's what it sounds like. Thread is IPv6 over 802.15.4. It's kind of like a little bit of a constrained variant of IPv6 to meet the needs of these low-powered embedded devices, but it is IPv6. The cool thing about that is that you're basically doing everything, you're doing all IP, even on your low-power radio segment, which means that communicating across network boundaries is much easier. So Thread and Matter in general introduces this concept of a border gateway router, which kind of replaces like a hub or a gateway with Zigbee or Z-Wave systems. But your Matter border gateway router really is just a protocol translation device. It takes packets off of either Wi-Fi or Thread on your internal network. It allows those devices to communicate with cloud services over the internet. That's a really flexible capability. I think it's a really cool thing to look forward to. How it's actually going to pan out, that's a little more up in the air. Thread devices are only just starting to appear on the market yet. I have not used any yet, so I'm going to withhold like lengthy judgment on how Thread works out until I have some experience with it. One of the reasons I don't have a Zigbee module hooked up right now is because I just recently ordered the Zigbee stick that Nabu Casa is selling. That's the company behind Home Assistant. And the cool thing about Zigbee and Thread both using 802.15.4 is you can implement them on the same device. So I call that a Zigbee stick. Nabu Casa, they're like working on a firmware update that will add Thread support. So I'm hoping once I get that in place, I'm going to have Zigbee and Thread available using that one device. And then I'm probably going to start picking up some Thread devices. My expectation is that Thread, when it comes to things like range and reliability, is going to be fairly similar to Zigbee since it relies on the same underlying protocol. But I do believe that the mesh routing is a little more flexible in Thread, so that might have a reliability benefit. The thing that I'm really hoping that Thread and Matter will deliver on is greatly improved interoperability. My experience, and maybe someone who's really big on Zigbee devices would argue with me here, but my experience is that Z-Wave is really the only home automation ecosystem that has pulled off reasonably good interoperability. You can buy a Zigbee device from basically any vendor, you can pair it to a hub from basically any other vendor, and they should basically work right. It shows up as the right kind of device, it's got the right controls, it's got the right sensors, because the Z-Wave protocol is very prescriptive about how you enumerate those capabilities. Matter provides that as well over IP and over the 6LoWPAN IP that is Thread. So hopefully it will extend that kind of interoperability into the realm of like our Wi-Fi devices. I don't really think Thread is going to deliver anything that's that impressive over Z-Wave, but I think it's going to get a lot more industry adoption because Thread and Matter kind of have the big vendors behind them in a way that Z-Wave never really has. Um, GE Jasco, I keep saying GE Jasco because it used to be GE, it turned into Jasco. You run into things that use the same names. GE sounds big, but it was really just a division of GE that they sold off. It's not that big. Honestly, one of the biggest companies behind Z-Wave is a European company called, I don't know if you're supposed to pronounce it EOTech or AOTech, but no one who isn't into Zigbee has ever heard of them. So Z-Wave has never really had like a big promoter behind it. Thread does. Basically, all of the big tech companies are kind of backing this Matter and Thread ecosystem. So it could be the future of interoperability. And if you give it 1 to 2 years, I might be replacing all of my Z-Wave stuff with Thread. I'm kind of hoping not, because that would be a pain. But that's the world of home automation, right? One of the problems is that you get a bunch of stuff working, and then like 2 years later it's obsolete and you want to swap out a bunch of it. The fact that Z-Wave has kept back compatibility makes that less of a problem, but then there's still enough benefits to the new Z-Wave generation that like now that 800 series is out, I kind of want to start replacing my 700 series devices with 800 series for the improved range and reliability. It's a tough thing with home automation, right? You're kind of putting your house onto the treadmill of consumer technology. I'll probably make a video in the future where I talk a bit about that issue specifically. One of the things that I like about Z-Wave is that its direct association capability makes it, I think, a lot more like selling your house proof than a lot of other home automation protocols are. You can make Z-Wave stuff pretty much work independent of like a hub, which is not really true of a lot of the other stuff out there. So that's it for now. I think this video has been kind of long and boring. I'm going to make another video. It's going to be a review of a Z-Wave device, and there's a real surprise in store for you with that video. I'm also hoping, as I said, to do some traveling this week, go kind of talk about an interesting place in New Mexico and some history there. I think military history people will enjoy that. If I'm not able to do that for whatever reason, my schedule's just kind of up in the air right now. There's something else I'm going to do. I'm going to do it eventually either way. It's going to be more of a Google Earth tour because I don't live near any of these sites. But I've got another kind of military history video coming up as well. That's going to be about sort of the direction of high frequency, or the history, sorry, the history of high frequency direction finding. Things like Wollenweber antennas or CDAA, circularly disposed antenna arrays, is I think what that stands for. And that's going to be an interesting topic because there's some cool historic sites that are scattered out there across the United States and Canada. One of my like kind of bucket list trips is to go to, is it Haida Gwaii? I don't actually know how you to pronounce it. The islands that are up north of like Vancouver Island. A lot of things I want to see there. One of them is a big Wollenweber CDAA that's still intact and I think even still in use by the Canadian Forces. So I'm not going to get to Canada to make that video because here's the thing. Canada is a long drive from where I am on the south edge of the United States. But I am going to show you some pictures and go over the history of one of the more interesting bits of military radio history in the United States. Oh yeah, don't forget to like, comment, and subscribe. There's a bell that you have to ring because of something about an algorithm, and that's just the world we live in.